All right, so I would not use substitution here because if you look at the coefficients of the variables, none of them are 1. All right, if I solve for x here, I'm going to end up with a fraction 3/2, right? You don't want to do that. So substitution is not the best way to do this one. You can, but it's not the best way. But look at this. If I add those two equations right off, if I add them up, if I add these two equations, what's 2x plus 2x? What's 3y negative 3y? And that's equal to what? I got x right away. What's my x coordinate? 3. X coordinate is 3. So I found the x coordinate of my solution. What's the x coordinate of my solution? 3. Now I've got to find the y coordinate of my solution. So going back to what we did in substitution, how do you find that other variable? You substitute. That's what you're going to do here. So wherever I see an x, I'm going to substitute what? 3. But you got to go back to one of these equations. It does not matter which one. You tell me which one you want to go to. First one? Okay. Because a lot of students don't like dealing with the negative. So I would go to the first because they're all positive. All right, so I'm going to get this. So I'm going to get 2 times x. What's x? 3. Plus 3y is equal to what? 6. And then all you got to do now is solve for what letter? Y. What's 2 times 3?
6.
So I get 6 plus 3y equals 6. To get y by itself, I'm going to do what next?
Subtract 6 from both sides.
So I get 3y equal 0. Then what's the next step? And so what's y? 0. So my solution is 3, 0. So the addition method, now that was easy, and then I'm about to look at one that's not so easy, but here's the idea. So I added right away, and I got x to be 3, and then I'm going to use substitution just like I did with the substitution method to find the other variable. Okay? Now check it. X is 3, y is 0. What's 2 times 3? 6. What's 3 times 0?
0.
Is 6 plus 0 equal to 6? Okay? Go back to the next one. What's 2 times 3?
6.
What's 3 times y? Is 6 minus 0 equal to 6? So that works. All right, now here's the idea behind addition. When I added these, what variable went away? Don't say middle. Y, right? Now look at the coefficients of y. What do you notice about the coefficients of y's? They're opposites. The word opposite is important here. So when the coefficients are opposites and you add them up, the variable goes away. And so that's going to be the idea behind addition. If I'm going to use the addition method, I need the coefficients of one of the variables to be what? Opposites. So if one is 8, the other one is what? Negative 8. If one is 6, the other one is negative 6. So in the addition method, I need the coefficients of one of the variables to be opposites. So let's look at number 2. All right, this one we have 4x plus 3y is equal to 15. 2x minus 5y is equal to 1. All right. Would you use substitution here? No, I would not use substitution here. There are going to be too many fractions, and chances are I'd make a mistake somewhere.
15.
That's a 15. 4x plus 3y equals 15. All right, can I use the addition method right away? Can I add those two equations? No. Because if I add them, that's going to be 6x, but minus 2y equals 16. It doesn't help. In order to add right away, the coefficients of one of the variables have to be opposites. Okay, so listen carefully. So you're going to pick a variable you want to eliminate. So step 1, choose a variable to eliminate. It doesn't matter which one.
I was using Bible.
Do we use a what? Addition. What variable do you want to choose first? It doesn't matter. I'll do both. But which one do you want me to do first? The x. All right. Now, let me just say this. You see how? Remember, opposites. One's positive, one's negative. So if one's a -7, the other one has to be what? Positive 7. See how the y already had a plus and a negative? It would have been better to just have gotten rid of the y's, but we'll do both. Okay, so if you want to eliminate the x, all right, now here's the idea. You have to find the LCD. You have to find the LCD of the coefficients of the x's. So right away, what are the coefficients of x's? 4 is one of them. What's the other? 2. What's the LCD? I said LCD. I should say least common multiple. Let me change that to least common multiple because those are not denominators, right? But the least common denominator, you're going to use the idea of least common multiple. But let's just use the word least common multiple. So is the least common multiple of the x's? What's the least common multiple of 4 and 2? 4. Least common multiple means the smallest number that 2 and 4 go into evenly. So that's 4, right? So think about the LCD. If this was, let's say, 1/2 plus 1/4, if this was 1/2 plus 1/4, thinking back 2 semesters ago or 3 semesters ago, what's the LCD? 4. So the least common multiple of 2 and 4 is what? 4. That's the idea. All right. So eliminate the x's. So the least common multiple of the x's is 4. All right. Now I'm going to rewrite this. Just rewrite it again. Okay, listen carefully. So I need the coefficients to be 4. That's what this says. I need the coefficient to be 4, but one's going to be positive, the other's going to be what? Negative, because they have to be opposites. Well, look at this. This is already a what? 4. Leave it alone. So leave this equation alone, because this already has a 4x. I need this coefficient then to be a what? Not a 4, but a what? -4. I need this coefficient to be a -4, because 4 and a -4 is what? 0. So what I'm going to do is I'm going to multiply both sides of this equation, multiply every term of both sides of this equation. Now listen carefully. 2 times what is a -4?
-2.
So you're going to multiply both sides by -2. So you're going to leave the first one alone because it already has a 4x. Huh? -2. And a -2 times a positive 2x is a what? -4x, and that's what you want. Right. So step 1 is to choose a variable to eliminate.
Every term or both sides?
Both sides. Which is every term, right? How many terms are there on both sides? How many terms are there on both sides?
I see.
3. A 2x, a -5y, and a what? 1. So every term has to be multiplied by -2. So most students, though, I shouldn't say most, some students, though, they'll do this part correctly and they forget to do the 1 by what? -2. So everything has to be multiplied by what? -2. All right, so step 1 is to choose a variable to eliminate, and so the least common multiple is 4. So then we have to multiply one or both equations by a number that gives me that least common multiple. All right, step 2 is to go ahead and rewrite the system. All right, so what's going to be my first equation? Okay, now go ahead and do distributing property. What do I get next? Equals a -2, right? So make sure you see that second equation. So every term has to be multiplied by -2. So the distributive property. So don't forget this times this times this, and this times this. Now can I do what? Add. So step 3 is to add them. What happens to the x's? So I get what? 13y equals 13, right? So what's y? 1. So y is 1. Once I get now found the y coordinate of my solution, so the y coordinate of my solution is 1. Now I've got to find what? X. So step 4 is to find x. So to find x, I'm going to substitute y equal 1 into one of these equations up here. Does it matter which one? No, does not matter. Which one do you want to? Now you go back. You got to use the original one. Don't go back to this one because you could have made an error here. Okay, always go back to the original. So which one do you want to choose? Okay. All right. So substitute y equal 1 into 4x plus 3y equal 15. All right. So I get 4x plus 3 times y. What's y? Equal 15. So 4x plus 3 equal 15. Subtract 3 from both sides. I get 4x equal 12. So it's x? 3. So I found my x coordinate. And the next step would be to check. But I'm not going to go ahead and check. I just don't have enough time. All right, so that will be the check. All right, so that's the addition method. Okay, let's do another one. Okay, number 3, still the addition method. Okay, let's look at this one. Number 3. Let's suppose you had this. Suppose you had. Let's do number 2 again because I said I was going to go back and do the other one. So let's do number 2. I'm sorry. Let's do that 2 star. So we have 4x plus 3y equal 15, and 2x minus 5y equal 1. So remember I said step 1 to pick a variable you want to eliminate. So let's suppose someone wanted to eliminate the y this time. So what's the least common multiple of 3 and 5? 15. All agree? So least common multiple of the coefficients of y's is 15. So one of these has to be a positive 15. The other one has to be a negative 15. So the next part here would be to you're going to have to multiply. You have to multiply this equation and that equation by a number that will make these coefficients opposites. Okay? So you have to multiply this equation by something and this equation by something so that these are opposites. And see how this is already a positive? So you want this coefficient to be what number then? Positive what though? 15. 15. You want this one to be a negative what? 15. All right, so let's look at this. Okay, so what do I need to multiply the first equation by to get this to be a positive 15? 5. So I'm going to put a 5 out here. What do I need to multiply this equation by to get a negative 15 here? 3. Okay, so I've got to multiply the first equation by 5 and the second equation by 3, and that will make the y's opposites. Now the next step is to go ahead and rewrite your system. Okay, so distribute, right? Every term, correct? Both sides of this equation, so every term. What's 5 times 4x? What's 5 times 3y? Don't forget the other side. What's 5 times 15? 75? Okay. Over here, what's 3 times 2x? What's 3 times a negative 5y? And what's 3 times 1? 3. All right. Now what can I do? Yeah, now I can add them. 20x plus 6x is? 15y negative 15y is? Equal 78. Divide both sides by 26. What do I get for x? 3. All right. So far my solution is 3 comma something. Now I've got to find what variable. Y. So the next step is to substitute x equals 3 into one of these equations. Which one do you want to use? First one. So substitute x equals 3 into 4x plus 3y equal 15. So we have 4 times 3, right? Plus 3y equal 15. So 12 plus 3y equal 15. What's the next step? Okay. 3y equal 3. And so therefore y equals what? 1. So you found your solution. So the solution is 3, 1. All right. Okay, let's look at 3. All right, suppose number 3, you had this. It's not that difficult. All right. All right, let's suppose we had this. Just all it is just remember the steps, but the manipulation's easy. That you should have. Okay, so you tell me what letter. I'm not going to do both this time. I'm running out of time with this one. Okay, want to limit the y? Okay. That's a -4. -4. Okay, so you want to limit the y's, right? So I got to find. So we're going to eliminate the y. So the LCM is going to be what? 12. All right, so I'm going to rewrite this. Okay, so in your mind, you know I've got to have a positive 12 and a what? Negative 12. Well, since these already have a plus and a minus, what that means is that I'm going to be multiplying by what kind of numbers? Positive. So what is I got to multiply -4 by to get a 12? Do you see this right here? Okay. What is I've got to multiply positive 3 by to get a 12? No. 4, right? No, don't say negative, because if you say negative, see, one's already negative, the other's positive. So -4 times a positive 3 is a -12. So I need this to be a positive 12. 3 times a positive 4 is a positive 12. Okay, now we're going to multiply all terms, or both sides, by these numbers. So what's my new system? Minus, equal, yep. Next one? 16. Now I do what to those? Add. So what do I get? Equal 17. So it's x. All right. So I found the x coordinate, right? Notice I didn't say step 1, step 2, step 3. It just flowed. Now I'm just writing it out. So solution, the x coordinate is 1. Now I got to find which coordinate. Y. So I'm going to substitute x equal 1 into, what do you want to go to? First one. So 3x minus 4y equal 11. So I already see an x, what do I plug in? 1. So I get 3 times 1 minus 4y equal 11. So I get 3 minus 4y equal 11. All right, what's the next step?
Subtract 3 from both sides.
All right, when I subtract 3 from both sides, combine like terms, I get negative 4y. And be careful, that's negative 4y, right? Okay, some students will say 4y. You got to be careful. That's negative 4y. Equal what? 8. What's the next step?
Divide by negative 4.
So negative 4 divided by negative 4 is 1. 1 times y is y, so what does y equal?
Negative 2.
So there are your solutions. And then you can check if you want to. Okay? All right, let's look at this one. All right, you have 3x equal 4y plus 1, and you have 3y equals 1 minus 4x. Okay, again, you want to do this by the addition method. Okay, so if you go back to the previous ones we've done, notice when you go back to the previous ones, and check all of them, the x's were aligned, the y's were aligned, equal, and then what? Your constants. So you'll notice the variables on one side, the constants are on the other. All right, so the first thing you got to do is make sure that the equations are in standard form. In standard form, meaning ax plus by equals c. So ax plus by equals c. So your variables on one side, constants on the other. So I got to rewrite this. So what does this become? Okay. What does this become? Yeah, because when I bring the negative 4x over, it becomes what? Positive 4x. And then what? Not minus 3y, plus 3y equal what? 1. What now? Okay. All right. Okay, which one do you want to eliminate? The y? What's the LCM? Okay, 12. Okay, so let me rewrite the system. 3x minus 4y equal 1. 4x plus 3y equal 1. So what do I need to multiply the first equation by to get a negative 12? 3. What do I need to multiply the second equation by to get a positive 12? All right. So my new system is going to be 9x. What else? What else? Equals 3. Over here, this becomes 16x plus 12y equal 4. Okay? Now what can I do? Add them. What's 9x plus 16x? 25x, right? Okay. Equal what? 7. So what does x equal? Yeah. All right. Now, according to the addition method, what's the next step you got to do? Plug that fraction back into one of those original equations, right? All right, but you're plugging back a fraction, so you have to deal with fractions. Well, you can get by without having to deal with substituting a fraction. All you do is this. Go back and eliminate the other variable. So you see how this is a fraction? I do not want to.
It's easier to do the negative and the positive one.
I do not want to go back and plug this back into x and having to figure out, well, what is 1 minus 4 times 7 over 25? I mean, you could, but whatever that is, you have to divide by what? 3. It's easier just to, see how I eliminate the y? Eliminate the x. So eliminate the x this time. What's the LCM of the x's here? 12. All right, and you do the process, same process. So I'm going to rewrite, so that means if I'm going to eliminate the x's. Now notice, see how these are both positive? Now one of my numbers will have to be what? And you determine which one it is. It does not matter. So I'm going to go ahead and rewrite the system. So in my math lab, one of the systems you have to solve, you're going to end up with a fraction. So just do elimination twice. Eliminate the x's, eliminate the y's. So what is I got to multiply this one by? Okay, you want -4. Okay, does not matter. Whether this is a 4 or a what? -4 does not matter. What do you want to eliminate this one by? 3. Now, if you make this negative, then you have to make this what? Positive. Okay. All right. So then I get what new system? Plus 16y equal -4, right? So don't forget, everything has to be multiplied by -4. What's the second equation? Equals 3. Now what can I do? So the x's go away. You get what? Equal -1. So what's your y coordinate? All right. So you're done. Your solutions are. What's x? What's y? There's your answer. Okay. So if you're whenever you eliminate the variable first, whatever it is, you get a fraction, just go ahead and do the elimination again with the other. Okay? All right. Now, let's look at this one. Let's write this number 5. Okay, so 3x minus 2y equal -5. 4x plus y equal 8. All right. And again, it does not matter which method you use, but you could use substitution here if you wanted to, correct? If you did substitution, which variable, which equation would you choose? Yeah, the second one, and what letter would you choose for? Would you solve for? What? It does not matter. All right, which one do you want to do? Substitution? Okay. Yeah, I think you need more practice in substitution than the addition method. So let's just do substitution. All right, so substitution, I'm going to pick the second equation and then solve for what? Solve for y. So now if I solve for y, that means I got to subtract 4x on both sides, right? Okay. So then I get y equal, and put the x first. So what does that become? Very good. All right, so that was the first thing I had to do. Now once you solve for y, then I go back and I substitute that into the other equation, correct? So then I substitute this expression here into the other equation. So the other one meaning, and this was y, so the other meaning this. All right. So we get 3x minus 2 times y. Now remember, you got to put parentheses, so what's y? You remember that? Put parentheses? Okay. And that's all that's going to equal what number? -5. So notice 3x minus 2y, and this is my y, equal -5. So now I'll just have an equation with just one variable, x. Now how do I deal with this one here now? Distribute. So 3x, what's the -2 times up -4x? Minus 16 equal -5. 11x minus 16 equal -5. Next step. And so I get 11x equal 11. So what does x equal? 1. All right. And then, so far my solution, x is 1. Okay, so then to find your y, you're going to back substitute into this equation, correct? So now we're going to substitute x equal 1 into y equal negative 4x plus 8, the one that was in step 1. So again, y equals negative 4 times x. What's x? Plus 8. So it's negative 4 plus 8, which is 4. All right, let's look at this one. Huh? You could go to the original, but remember, when using substitution, you could also go back to the one that you found in step 1. But you can go back to the original. You're supposed to go back to the original. And the reason you want to go back to the original is because you could have done what here? You could have made an error. But if you're certain that you didn't make an error, then can't you use this? Yeah. All right. If you go back to the original, you got to pick one of these. Which one do you want to use? First one. So instead of going here, you could say this. So substitute x equal 1 into 3x minus 2y equal negative 5. So we're seeing x, what are you going to plug in? So I get 3 times 1, right? Minus 2y equal a negative 5. So that's 3 minus 2y equal a negative 5. What's the next step? Subtract 3. So negative 2y equal negative 8. What's the next step? Negative 2. So what does y equal? And that's what this was. So that's what you have to do if you go back to one of the originals. You still get the same answer, correct? Okay. All right, let's get this one. We'll do one more with this. Okay, let's look at this one. And then we're gonna look at the distance formula. It's just plug and chug in the distance formula. All right, write this down. And I'm going to go ahead and use substitution because you need more practice substitution. Addition is easier compared to substitution. Okay, if you're going to use substitution, which equation are you going to use? And solve for what letter? X. I'm going to solve for x. So I'm going to pick x plus 3y equal 2. I'm going to solve for x. So that means I have to subtract 3 off from both sides, correct? So what does x equal? Okay. All right, so now I'm going to substitute the expression negative 3y plus 2, because that's what x equals, into the other equation. Right? And what was the other equation? Yeah, so the other equation. So in place of, remember that was x, so in place of x, I'm going to substitute this. Okay? So I get 3 times, in parentheses, what do we put in parentheses? Plus equal 6. Now do what? So I get negative 9y plus 2 plus 9y plus 8 plus 6. Yes, thank you. Plus 6 equal 6, right? Combine like terms. What's negative 9y and a positive 9y? So the variables disappear. So what's left? 6 equals 6. Okay? So remember, we talked about when we solved equations, we talked about that if the variables disappear, then either you get what? All real numbers, or you can get what? No solution. You got to determine which one it is. Because this equation is a true statement. That's a true statement, right? Okay. All right. Now, In terms of the graphing, here's what that means. You remember in the lesson I asked you to look at? The lesson I asked you to look at, so one of three things can occur. The graphs could intersect at one point, in which case you have how many solutions? One solution. The graphs could end up being parallel. Now remember, a system has a solution if they intersect. So what do you notice about parallel lines? They don't intersect. So if the equations are parallel, then this would have no solution, correct? Or it could be that the two equations overlap. So these are two equations, in which case you have how many solutions? An infinite number. Okay, infinite number of solutions. Okay, which is what this is. So if you were to graph this, if you were to graph these two equations, you'd be graphing the same line. So these graphs are the same line. So the graph of x plus 3y equal 2 and 3x plus 9y equals 6 coincide. They overlap. They're the same graph. So you get how many solutions? An infinite number of solutions. Okay? Get an infinite number of solutions. Now your book though, now some books will, if you say infinite number of solutions, that will suffice. But your book does not. Your book wants you to say something else. It is still an infinite number of solutions, but here's how your book wants to indicate that. All right. So you can indicate your solutions. In my math lab, you're going to have to do the same thing as, and you're going to write like this, is the set of ordered pairs xy, set of ordered pairs xy. Now, those of you that had me last semester, remember what this is called? What phrase is this? Such that. Such that. And then all you do is just rewrite one of these equations. It does not matter which one. Such that you use one of these. Such that x plus 3y has to equal what? 2. All right. And here's why. When you say an infinite number of solutions, and let's say my graphs, these were my graphs, okay? I'm making this up. And you say there's an infinite number. Sometimes students think this. Sometimes students think that any number in this plane is a solution. Is that true?
No.
No. But they think that because I'm using what phrase? Infinite number. Anything works, right? But that's not true. What points are the only one that works? The points that are on this line. And this line is represented with this equation. It's still an infinite number of solutions because you can't count all these, but they are located where? On this line only. All right, so that's how you write it. So you say the set of x's, the set of ordered pairs such that, and you just rewrite this line as the equation. And it didn't matter which one you use. You could use this one, or you could choose this one. Okay? All right. Now, on my math lab, and this is actually on worksheet 3, which I did print out. I forgot to, because I'll give it to you next time. But suppose, and I don't have time to do it because I need to do something at least with the distance formula. Suppose that I solve the system. Okay, I have a system. Actually, let's do this. Let's rewrite it as this. X plus 3y equal 7. And, okay, 3x plus 9y equal 4. So let's do that. Huh? No, the one we did earlier a while ago, one was 7, the other was 6, I think. Right? Or 2 and 6. Okay, so let's do substitution again. What are you going to choose?
The first one.
Okay, so we're going to pick x plus 3y equals 7 and solve for x. So I get x equal negative 3y plus 7, right? Okay, now I'm going to substitute this expression into the other equation in place of what letter? X. Crap. Change this to, sorry guys. Oh, not this one. I'm sorry, not this one. Which one? The second one, right? I'm sorry, y'all didn't say anything. Okay. So then we get this. We get 3 times x. What's x? Plus 9y equal what? 4. Okay, distribute. Negative 9y plus 21 plus 9y equal 4. What do you do with the y's? So you're left with, right? Again, the variables disappear, but this time the statement is false. So remember, when the variables disappear, either it's all real numbers or no solution. Which one is this one? No solution. So in the blank, you would put no solution. Nothing would work. So what does that mean about these two graphs? They're parallel. And it kind of makes sense. Watch. Let me just show you. Remember, so the graphs are parallel, right? Y'all agree? All right, now watch. If I get, remember, slope-intercept form, y equals mx plus b? You remember that from last semester? So if I solve for y, watch what happens. If I solve for y, I'm going to subtract x from both sides. So I get 3y equal negative x plus 7, correct? Then divide by what? 3. I'm going to divide every term by 3. Y'all agree? 3, 3, 3. So I get y equals, do y'all agree, first of all, that negative 1x over 3 is the same thing as saying negative 1/3 x? Yes or no? Okay. What's the slope? Negative 1/3. Y'all agree? All right. What's the y-intercept? 7/3. You remember all that? Slope and y-intercept? If I do the other one, watch what happens. The other one is this, 3x plus 9y equal 4. Now you don't do all this. Now there is a section we're going to do soon that talks about slope-intercept form, but I'm just want to do this now because I want to show you those lines are parallel. 9y equal, bring the x over, what do I get? Divide both sides by what? Okay, so I get y equals, negative 3/9 is the same thing as saying what? Negative 1/3. Plus 4/9. Okay, what do you notice about those two lines? The same slope. So if two lines have the same slope, they're parallel, only if the intercepts are what? Different. All right, so notice same slope, different y-intercepts. So they are what? They are parallel. Okay, so that was this part was a quick, and I did this quick. This part was a quick review from, now this is actually Math 98. You didn't do that in Math 99. That was Math 98. Okay? Now, one of the other things they're going to tell you, they're going to ask you about number 6 and 7 is this. So, okay, so identify, okay, no, that's it. That's all they wanted you to do. All right, so remember that if the variables disappear and it's a false statement, you just say what? In your mind, though, you know that the graphs are going to be what? Parallel. And then here's an example where they were parallel. Here, if the variable disappears, I think it was this one, if the variable disappears, this was a true statement, but in my math lab and on the worksheet, and it's actually worksheet 3, which I haven't given to you, but when I give you worksheet 3, if there's an infinite number of solutions, don't say infinite number of solutions. How are you going to write it? No. You're going to write like this. Okay, like that, right? You're going to say your solutions are set of ordered pairs such that, and all you do, guys, is just write out one of the equations. Doesn't matter which one. Okay? So don't forget that. Okay, so that takes care of that. You okay with 8.1? Just go back and review.